Alright, this video for 3VT about exercise 63 from chapter 9. This one is a bit more difficult than the previous exercise we did, because all of these sub-questions are about something completely different. But let's see if we can figure out all of them. The first one, I'll read it out loud. It says, there are 8 athletes at a 100-meter final. How many ways of awarding the gold, silver and bronze medals are possible? Okay, so one of those 8 is going to win the gold medal. And then one person is going to win the silver medal, and then one person is going to win the bronze medal. So the number of possibilities you have is as follows. First we have, there are 8 athletes, so for the gold medal, one of those 8 is going to win. Now if you already win the gold medal, you can't win the silver medal at the same race, right? That will be kind of weird. So then we have 7 athletes, and one of them wins the silver medal. And then of the remaining 6, one of them wins the bronze medal. The number of different possibilities to award these medals is 8 times 7 times 6, so you can award them in 336 different ways. Moving on to exercise B. There it says, sorry for the lighting, it's a bit annoying. There are 6 single rooms in a hotel. One evening, 4 guests arrive to stay at the hotel. How many ways of assigning each guest to a room are possible? Okay, so 4 guests arrive at the hotel, right? So the first guest that arrives has 6 rooms, and they're going to choose one, and then that guest stays in that room. So for the next guest, there are 5 rooms left, and for the next guest 4, and then 3. So the number of possibilities to divide these guests over the room is 6 times 5 times 4 times 3. So that's 30 times 12 is 360 different possibilities to do that. The next exercise, exercise C, is about Rita. Rita completes a test consists of 12 multiple choice questions, each with 4 possible answers. She guesses every single answer. How many ways can Rita complete the test? Okay, so there are 12 questions, right? For every question there are 4 possible answers. So for the first question you have 4 answers you can choose from. For the second one you have 4 answers you can choose from, etc. So it's going to be 4 times 4 times 4, and that 12 times in total. So a shorter way to write that down is 4 to the power of 12. And if you do 4 to the power of 12, you have 16,777,216. So if you ever have to make a multiple choice test where every answer is 4, where every question has 4 answers, the chances of you getting a 10 when you guess everything is 1 out of 16 million. So those are not very good odds. Here we have exercise D. There are 10 chairs in Dr. Wood's waiting room. At the start of his clinic hours, 6 patients enter the waiting room. How many possible ways are there for them to sit in the chairs? So this is very similar to exercise B, but now it's about chairs and not about rooms. So there are 10 chairs in total, and there are 6 patients that come in. So the first patient sits on one of those 10 chairs, then the next one on one of those 9 remaining chairs, and then 8, and then let me check how many patients were there. 6, right? So times 6, 7 times 6 times 5. So this is how many ways there are possible for them to sit down. Let me calculate what this is. This is in 151,200 different possibilities for them to sit in the room. Exercise E. Actually, they should have made this E, F, G, H, because you have to calculate something 4 times. But it's about Marianne, and she makes 4-letter words. Non-existent words, like the one you see here. Key, B, B, I don't know how to pronounce that, right? So, those are also permitted. How many words are possible when she only uses vowels, when she only uses consonants? She uses 4 different letters for each word, and for the last one, when she chooses the order vowel, consonant each time. So you have to calculate these 4 things simultaneously. If you don't know what the vowels are, here they are. There are 5 vowels in total, so there are 21 consonants. So if she can only use vowels, that means that it has to be one of those 5 things, alright? So if she makes a 4-letter code, it's going to be 5 times 5 times 5 times 5, which is 625 different codes. For the next sub-question here, if she uses only consonants, it would be 21 times 21 times 21 times 21, which is kind of a big number. Let me check what that is. It's 194,481. If she uses 4 different letters for each word, this sub-question does not say it has to be vowels or consonants, so you can use both. The only thing is, if you already used one letter, you can't use it again, because all the letters should be different. So it's 26 times 25 times 24 times 23. So if you calculate that, you get, let me check, 358,800. Yeah, so this is an 8. It's a very weird 8 here. I want to do it again. An 8. Yes. And for the last sub-question, she chooses the order vowel, consonant each time. And the question does not say that you cannot repeat them, so I'm going to assume that we can repeat them. So it's going to be 5 times 21 times 5 times 21. So let's see what that is. 5 times 21 times 5 times 21 is 11,025. That's how many codes you can make then. So these are the answers for 63. Thank you very much for watching, and I'll see you in another video. Bye bye.